This is part 3 of section 5.1. We want to solve this system of equations by elimination or the addition method, the name this book calls it. And I need to get rid of either x or y. Now, in general, I would tell you that in this case, it would be easier to get rid of y because it already has opposite signs. But I need to show you how to create opposite signs if you don't have them already. And we have never found y first. So just because I want you to see what happens here, I'm going to try to get rid of x. So look at the 2 and the 5. If these were denominators, your common denominator would be a 10. So I'm going to try to create these, make these 10s, a positive 10 and a negative 10. Well, to make the 2x into a 10, I would need to multiply it by a 5. To turn the 5 into a 10, I would need to multiply that by a 2. Right now, I have positive 10 on both of them. I need one of them to be negative, so you simply force one of them to be negative. It doesn't matter whether you choose the top one or the bottom one, does not matter whatsoever. You'll end up with the same answer no matter what. So, I am going to multiply this entire first equation by a negative 5. That will give me negative 10x minus 15y is equal to positive 80. Now let's distribute the 2 through here. That's going to be 10x minus 20y is equal to 60. Okay, double checking my work here. Now our x's cancel out, and we end up with, that's going to be negative 35y is equal to 140. Now, if you divide both sides by negative 35, you get your y value is negative 4. Now let's take this value and plug it into one of these two equations. Simply because this one has smaller numbers, I'm choosing the top one. There's no other good reason. This would be 2x plus 3 times negative 4 is equal to negative 16. So 2x minus 12 equals negative 16. Move the 12 over here, and we get 2x is equal to negative 4. So x must equal negative 2. Not really that different, solving for y first. So generally speaking, you want to go with the one that looks easier. The biggest mistake I see when you find y first is people write their ordered pair with the y value first. You know your ordered pairs have to be x and then y. So make sure that's how you write your answer. Okay, so we've talked about 2 major methods for solving these. Well, technically 3 because we talked about graphing. We just didn't work them that way. And now we're going to have some where just solve by the method of your choice. So most people end up with a preference in general about substitution or elimination addition. But some problems are set up for one. So even if, for example, this one's already solved for y, so substitution is going to be easier here. Now, if you really don't like substitution, you can rearrange things and make this into an addition problem. But it's set up for substitution. Okay, so since that's set up for substitution, I'm going to take all of this and plug it in for this y value right here. So that would be 6x plus 2 times 2 minus 3x is equal to 7. Distribute the 2. 6x plus 4 minus 6x is equal to 7. Now, something weird happens here. Those cancel out, and I end up with 4 equal to 7. Now it's obvious something weird is happening here, okay? Let's think back to what we were talking about. We use the graphing language a whole lot. Well, most of the time, if you graph any two lines, they're going to cross somewhere. But it is possible that you have two lines that are parallel and never cross. Okay, and that also means you have no solution. The other possibility, the other special case, would be that you graph your first line, and then you graph your second line and realize that they are the same line written in two different forms. Okay, and then if your answer is in usual where the lines cross, or the one point where they have in common, well, here they cross, quote unquote, or the points they have in common are every single one. Okay, and this one would have infinite solutions. Now, how do you know which of these two special cases you have? Well, first of all, on both of them, your variables cancel out. And this is going to happen whether you use substitution or elimination, addition. So they're both are going to cancel out. Now, this case, you end up with something false. Okay, and then if you have this case, you end up with something true. Okay, so which of these two cases do I have? Well, I ended up with 4 equal to 7, which is definitely not true. So what I have here are a case of parallel lines. Now, you remember that when we dealt with parallel lines earlier in the course, we compared their slopes. And it's true that if you solved this one for y, you would see that you had the same slope as you do here. But so, how do we write our answers here? We say that this kind of system, we call it inconsistent. So this is an inconsistent system. These are parallel lines. Okay, because they might ask you this as well. And you might also see the no solution. There is no ordered pair that I could plug into both of these that would work. Okay? Now, this other case is called a dependent system. And we'll have to talk about how to write our answers when we have one of those. Okay, last problem. And we are supposed to solve this using either method. I again see that this is solved for y, so it's pretty much set up for substitution. I'm going to take all of this and plug it in right there for that y value. So that gives me 9x minus 3 times 3x minus 4, and that's equal to 12. Distribute the negative 3. All right, and I end up with my x values canceling out, and I am left with 12 is equal to 12. So since my variables cancel out, I know I have one of my two special cases. This is true. So what does that mean? It means that it is a dependent system. We have the same line and we have infinite solutions. Okay. Okay, if you graph these, they would be the same line. And so that means it has infinite solutions. And by the way, infinite does not mean all real numbers. The only solutions we have are the ones that are on that particular line. Every single point here, and there are infinite points on that line. But this point over here is not a solution. So it's infinite, but not everything. Now, the last bit of this is they're going to ask you to write your answer in set builder notation. Okay, now they'll provide you with the beginning of this. It will be on all of these problems. They'll give you a system, ask you to solve it. The first choice will be there is a solution, it's this ordered pair. The second one would be that this is an inconsistent system, it has no solution. And then they would have dependent. You would pick the bullet by that. And it would probably have this much provided for you. And right here, you have a blank that you're supposed to fill in. This is read as the set of all xy, or the set of all ordered pairs, such that this is sort of like a condition. Every ordered pair as long as whatever I put right here. Now, what do you put right here? You want to put a simplified equation right there. And if I look at these two, you can see that this is in slope-intercept form, and it is one of our two major simplified examples, simplified forms. We always simplify things either into general form or slope-intercept form. So I'm just going to put all of this in here. Y is equal to 3x minus 4. By the way, if you rearranged this and put it in slope-intercept form, you would, when you rearrange this, you're also going to get y is equal to 3x minus 4, which makes it extremely obvious that you are dealing with the same line. Now, in the next sections, we're going to be taking some of these methods and expanding them to 3 variables.